Hi and welcome to the video section A2, video 2. This will be continuation of our polar graphs, specifically graphing a cardioid or a cardoid. So cardioid or cardoid sounds like what? Cardiac, which is what? It's a heart. That's what we're going to be graphing here. A heart. So, let's look at the following example. Let's say we want to sketch r is equal to 2 plus 2 cosine of theta. So we're going to be using our polar graph again. I'm just going to draw the graph with the rings on it so I know how many units I'm away from the center. So before I start drawing this graph, I don't want to plot points. If that's worst case scenario, go ahead. But instead, let's look at the transformation of this equation. So if this was y is equal to 2 plus 2 cosine of x. So what does this do? If we look at just cosine of x, that's our basic cosine graph, the 2 does what? It doubles it, and then the 2 on the front is our vertical shift. So if you remember from exam 1, we were doing transformations of graphs. Same idea. If this was the problem we're given, we could do this as a transformation. So if we have our point at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this doubling and then shifting up 2 means that our points are actually in these locations here. 0, 4, pi over 2, 2. At pi we're at 0, back up to 2, back up to 4. Why do I do that? Well, because I can do that transformation and then figure out on this graph where those points should be. So, when I'm at 0 radians, I should be 4 units away from the origin. So at 0, I'm 4 units away, which puts me out here. At pi over 2, which is my vertical piece, I should be 2 units away. So that means I'm out here. So from the origin along pi over 2, 1, 2 units. At pi, I'm 0 units away. So pi is off to the left, but I need to move 0 units out that way, which means I'm here. 3 pi over 2, I'm back out to 2 units. And then at 2 pi, as I make my way totally around the circle, I'm back out to 4 units, which is here. So it's kind of hard to see with these 4 points, but essentially what we get, and as we go from pi over 2 to pi, what happens? From pi over 2 to pi, we get closer and closer and closer to 0. And then from pi, we start moving away from 0 out to 3 pi over 2. So that's what this graph does. It comes here, gets closer and closer to this point, gets closer and closer to 0, stops, then starts moving away, hits that point, and comes back around to where we started. So you can see it's basically looking like a heart pointing off to the right side. So that's what you can do if you don't remember the general form, which I'll give you here in a minute. If you don't remember the general form and what it means and which way it's pointing, just go back to your basic sine or cosine graph and then plot those points. So, as I said, we have our in general here. So just like we had the general equation for the circles in video 1, we have the general equation for the cardoids here in video 2. And we have the following. R is equal to A times 1 plus or minus cosine of theta. R is equal to A, 1 plus or minus sine of theta. So and that's what we have here. If we wanted to rewrite this in terms of that, we basically have 2 times 1 plus cosine of theta. Our A is 2, 1 plus cosine of theta inside. So for cosine of theta, when it's positive, it's a heart pointing to the right. So that's what you can see here, pointing off to the right. If it's minus, it's a heart pointing off to the left. And then for sine, if it's positive, it's a heart pointing upward. And if it's negative, it's a heart pointing downward. As far as this value of A, this tells me from the origin, if I'm, in this case, I have a heart pointing to the right, how far do I go out, up and down, to get to these points on the heart? So up and down, or left and right. So if I have a sine curve, then I'm going to be going out to the left and right, depending on whether I'm pointing up or down. And then how far away is the point of the heart? Well, it's 2 times A. So that's sort of a shortcut. In this case, our A was 2. 2 times 2 is 4, so that's how many units I move out from the origin. So let's look at another example. So if you want to pause that, write that stuff down. I'll leave the in general graph so we can reference back to that. So for this one, I want to sketch R is equal to 2 minus 2 sine of theta. So if I want to rewrite this, if I factor out a 2, I get 1 minus sine of theta. So let me sketch my graph here with the couple of rings. So let's see what we have here. First, we're talking about sine. So this is going to be a heart that points up or down. Because I have a minus, that means the tip of the heart is pointing downward. I have the 2 in front. That's my value for A. So I know I'm going to have, because it's a heart, I have a point at the origin. The 2 tells me how far out to the left and right I go. So 2 units this way, 2 units to the left. And then lastly, if I do 2 times A, or 2 times 2, that's 4. Because I know, because it's a minus sign, the heart's pointing down, I need to move 4 units downward. That's where the tip of the heart will be. That puts me there. So now, if I connect these dots, I know it has to be a heart. Whoops, excuse me here. So one thing I'll say, you should get a picture like that. Notice how the bottom, even though in my little graphics there it's pointy, when we're graphing cardoids or heart graphs, the bottom or the top or the side has to always be smooth. The only point we have is right at the 0. So that gives us that graph. So if you really want to impress your significant other, instead of tonight when you send them that text, saying good night, love you, say good night, R equals 2 minus 2 sine of theta. They'll probably think you're nuts, but you'll know that in your head that's your symbol for the heart. You won't have to do the emoji. This can be the new emoji for the heart symbol. That's it. That's the end of video 2, our graphs on cardoids. Come on back and we'll look at some roses.